In this video, we're going to solve question 25 of the 2021 Junior Mathematics Olympiad first round. We're told that we have a triangle ABC with side lengths 11, 60, and 61. And we're asked to find the radius of the circle that passes through the three vertices of this triangle. So, in essence, we're asked to find the second radius of this triangle. So, what is the second radius of a triangle? The second radius of a triangle is the radius of a circle, of the circle that passes through the three vertices of a triangle. So let me have a diagram here to illustrate it. So here we have a triangle, and then we have a circle that passes through all three vertices of this triangle. The second radius of this triangle here that we have is the radius of this circle that passes through all the 3 points of this triangle. That's this radius R here. So it's denoted by a capital R. So in solving this question, we're going to make use of a formula that relates the area of a triangle, the three sides of that triangle, and the second radius of that triangle. So the formula I'm talking about is the formula A equals ABC divided by 4R. So the area of a triangle is equal to the product of the side lengths of that triangle divided by 4 times the radius of that triangle. So this is the formula we're going to make use of in solving this question. So now to be able to use this, we already know what the three side lengths are, but to find the second radius of this triangle, we need to know what the area of this triangle will be, and we're going to find that next. And if you look at the three side lengths of this triangle, the side lengths are 11, 60, and 61, and these three numbers here are a Pythagorean triple because 11 squared plus 60 squared equals 61 squared. If you want to go about verifying, if you want to go about verifying this, one way you can go about it would just be to move 60 squared to the right hand side. You have 11 squared equals 61 squared minus 60 squared, and you have 11 squared to be 61 plus 60 times 61 minus 60. Then you have 11 squared to be 121, right? And this is true, meaning that this here too is true. So that's how we know that 11, 60, and 61 are a Pythagorean triple. So since 11, 60, and 61 are a Pythagorean triple, it means that this triangle here is a right angled triangle with two should I call them side lengths 11, 60, and then a hypotenuse of 61. So since 11 squared plus 60 squared is equal to 61 squared. And if this is the case, then the area of this triangle here, since it's a right angled triangle, will be half of the product of the base and the height, which will be 11 times 60 divided by 2. And so the area here will be 11 times 30, and the area will be 330. So 330 is the area of this triangle that we have here. And now we're going to use that to find what the second radius of this triangle is. So we have once again that A equals ABC over 4R. Remember, A is the area of the triangle, ABC are the side lengths, and R is the second radius. And since we know that the area is 330, we have 330 equals ABC will be 11 times 60 times 61 divided by 4 times the second radius, which is what we're looking for. And so 11 goes here once, and 11 goes here 30 times, and then we can cancel out 1 0 from 60 and 1 0 from here. Then you have 3 equals 6 times 61 divided by 4, divided by 4R. And then we're going to multiply both sides by R over 3. So multiply both sides by R and divide both sides by 3. Once you do that, you have R equals 6 times 61 divided by 12. And then 6 in 6 is 1, and 6 in 12 is 2. So R will be 61 divided by 2, which is 30.5. So the second radius of this circle, of this triangle here, is 30.5. That's the radius of the circle that will pass through, or that passes through all three vertices of this triangle, is 30.5. This is how to go about solving this question.